In this video, we will discuss simplifying radicals and rationalizing denominators. Simplifying radicals. An expression involving radicals is in simplest form when the following conditions are satisfied. All possible factors have been removed from the radical. All fractions have radical-free denominators, accomplished by a process called rationalizing the denominator. The index of the radical is reduced. To simplify a radical, factor the radicand into factors whose exponents are multiples of the index. The roots of these factors are written outside the radical, and the leftover factors make up the new radicand. Example: simplifying even roots. Here you see in example A, the fourth root of 48. We can break this up into a perfect fourth power. So we can have the fourth root of 16 times 3. We can rewrite 16 as 2 to the fourth power. And as we have seen before, when we have a 4 and another 4, those 4's cancel. So we are left with a 2 outside of the radical. The leftover factor of 3 is now the only part of our radicand. In example B, we have the square root of 75x cubed. Since we have a square root, we want to look for a perfect square. Notice that 25x squared is a perfect square. And then left over we have 3x. The square root of 25x squared is 5x, leaving us with a radicand underneath our square root of 3x. In example C, we have the fourth root of 5x to the fourth power. Because this is an even root, we need to have the absolute value of 5x. Notice though that no matter what value we substitute for x, we'll never change the fact that 5 is positive. So we can remove that 5 from the absolute value so that we have 5 times the absolute value of x. Another example we have here is simplifying odd roots. So here we have the cubed root of 24. Now that we have a cube, we want to make sure that we find a perfect cube, not a perfect square. Here we have 8 times 3, where 8 is a perfect cube. 8 is 2 cubed, so again we can pull 2 out and be left with the cubed root of 3 underneath the radical. In example B, we have the cubed root of 24a to the fourth power. Notice this time that the perfect cube is 8a cubed, and that is being multiplied by the leftover factor of 3a. Since the cubed root of 8a cubed is 2a, we can pull that out so that we have 2a times the cube root of 3a. Additionally, we have the cubed root of negative 40x to the sixth power. Remember that when we have odd roots, we can have negatives in the radicand. So we'll break this up And we want that negative to be part of the perfect cube. So we'll make our perfect cube negative 8x to the 6th, and our leftover factor is 5. So the cubed root of negative 2x squared, quantity cubed, times 5. So we can bring out the negative 2x squared and have that multiplied by the cubed root of 5. Let's take a look now at a method to combine radicals. Note that you can only combine radicals if your radicand is the same and your index is the same. So we can only combine square roots with other square roots, but also they have to be the same underneath the square root. So let's break up the square root of 48. So we'll have 2 times the square root of 16 times 3 minus 3 times the square root of 9 times 3. So we have 2 times the square root of 16 is 4, and we need to keep the square root of 3 as our radicand, minus 3 times the square root of 9 is 3, and then the square root of 3. This will simplify. 2 times 4 root 3 is 8 root 3, minus 3 times 3 root 3 is 9 root 3. And then just as we would subtract 8x minus 9x, we can take 8 square roots of 3 minus 9 square roots of 3 to get negative square root 3. In our next example, we are looking at the cubed root of 16x minus the cubed root of 54x squared. The cubed root of 16x, we can break that up into 8, which is a perfect cube, times 2x. And the cubed root of 54x to the 4th, we can break that up into a perfect cube, 27, times x cubed, and then left over we have 2x. When we simplify this, we would have 2 times the cubed root of 2x minus the cubed root of 27 is 3. The cubed root of x cubed is x, so minus 3x times the cube root of 2x. Because we have the cubed root of 2x in both of these, we actually want to rewrite this in a form of 2 minus 3x times the cubed root of 2x. So this is kind of like undoing a distributive property. More formally, we call that factoring, and we'll get into that in another series of videos. The remainder of this video will focus on rationalizing denominators. To rationalize a single term denominator, let's take a look at problem A. Here we have 5 over 2 root 3. Now, just like we cannot have 0 in our denominator, and we don't like negative exponents in our denominator, we also don't like to have square roots in our denominator. So we need to rationalize this, which is a form of rewriting it. We don't want to change what this expression means. We just want to change how it looks. So we will multiply it by a form of 1, because that won't change its meaning, but it will change how it looks. Notice here that the 2 is okay to have in the denominator, but we have a square root of 3. The way to rationalize this is to multiply by the square root of 3 over the square root of 3. This is the form of 1 that is going to change what this looks like, but not what it means. So when we multiply, we treat this as fractions. We multiply straight across. So 5 times the square root of 3 will just be 5 root 3 over 2. The square root of 3 times the square root of 3, you can think about, if you need to, as the square root of 9. But we know that the square root of 9 is 3, so this becomes 5 root 3 over 2 times 3, which simplifies finally to 5 root 3 over 6. Let's take a look then at B. So we have 2 over the cubed root of 5. Here we have a cube root. So in order for that to cancel, we need our total exponents underneath the radical to be 3. What we need to multiply this particular expression by is not the cubed root of 5. That would only give us, in our denominator, the cubed root of 5 squared, which still leaves us with a radical in our denominator. What we need to multiply is the cubed root of 5 squared. So this is going to work because in our numerator, we will be left with 2 times the cubed root of 5 squared. And this is okay to have because the 2 underneath the radical is smaller than 3 outside. Over the cubed root of 5 times 5 squared, which is 5 to the 3rd power. But if you remember, when we have a cube and a cube root, those cancel. So this is all over just 5. Rationalizing a denominator with 2 terms is a bit different than rationalizing a denominator with just 1 radical term. So here we need to make use of something called the conjugate. The conjugate is simply the denominator with the opposite sign. So for this particular example, the conjugate is going to be 3 minus the square root of 7. Again, it is your denominator, just with a change of sign. So to rationalize 2 over 3 plus the square root of 7. We're again going to multiply by our factor of 1. This time, however, our factor of 1 looks like 3 minus root 7 over 3 minus root 7. Here we need to take and use some distributive property and some FOIL method. So in the numerator, we have 2 times the quantity 3 minus root 7. So 2 times 3 is 6 minus 2 root 7. And then in the denominator, we need to apply the FOIL method. So we multiply our first terms of these binomials. 3 times 3 is 9. 3 times negative root 7 is going to be minus 3 root 7. The square root of 7 times 3 will be plus 3 times the square root of 7. And then finally we have the square root of 7 times the square root of 7, which will be minus the square root of 49. So obviously we have some cleaning up to do in this denominator. But before we start that, I want you to take a look at these 2 middle terms. So here you have negative 3 root 7 plus 3 root 7, and this adds to 0. So both of these center terms cancel, which is perfect because that's going to help us eliminate the square roots in the denominator. So let's simplify this now. We have 6 minus 2 times the square root of 7 in our numerator. 9, remember this all canceled out to 0, minus the square root of 49. Well, the square root of 49 is 7. So here we are then left with 6 minus 2 root 7 over 2. Let's go ahead and factor out a 2 in the numerator. That will leave us with 3 minus the square root of 7. Again, if we distributed this back through this 2, we would get 6 minus 2 root 7. And that's going to be over 2. We can cancel those 2's by division, and we're left with 3 minus the square root of 7.